While the internet was busy joking about the Cybertruck or watching the Tesla bot try its clumsy dance moves, Elon Musk might have quietly pulled off something far more significant. Something that could signal the beginning of the end for lithium batteries at Tesla. As Elon himself stated, "We have spent a great deal of effort on this over many years, mostly internally, though some important acquisitions also played a major role in lowering the cost per kilowatt hour. No grand unveiling, no flashy social media posts, but let there be no doubt Tesla is preparing to move beyond lithium and towards something faster, more cost-effective, and safer: aluminum ion. And if the rumors are accurate, the very first Tesla to benefit from this groundbreaking battery will not be a high-end roadster or luxury SUV. It will be the ultra-affordable Model 2, expected to cost around $10,000. You are watching AMP Drive, where we bring you the future before it becomes news. If you're excited by these silent revolutions and massive innovations, please consider subscribing. We are a small but passionate channel with fewer than 1,000 subscribers, and your support means the world. Hit that button and be part of the ride as we uncover what is really happening behind the scenes at Tesla. So let's dive into this journey. What exactly is aluminum ion, and how does it differ from the batteries we currently use? Aluminum ion batteries use a totally different kind of chemistry compared to lithium ion ones. While lithium ions carry a single positive charge, aluminum ions carry 3. That means each aluminum ion can move more electrons, making the battery more efficient and able to deliver higher current density. This allows more power to flow within the battery in a smaller space. In theory, aluminum ion batteries could achieve specific capacities over 2,980 mAh per gram at the anode level. That is almost 10 times the capacity of the graphite anodes used in lithium-ion batteries, which usually offer around 370 mAh per gram. What does this mean in practice? A smaller battery with more power, output perfect for electric vehicles that need quick acceleration and reliable long-distance range. AID. One huge advantage of aluminum-ion technology is that it does not rely on materials that are hard to find or expensive. Traditional lithium-ion batteries need cobalt, nickel, and manganese-all, of which are costly and come from unstable sources. For example, cobalt prices have bounced between $30,000 and $80,000 United States dollars per metric ton in the past 5 years. Largely because of political issues and unethical mining practices, especially in places like the Democratic Republic of Congo. On the other hand, aluminum is far more available, trading at around $2,200 per metric ton and mined in more than 40 countries, including top producers like China, India, and Australia. This makes aluminum-ion batteries much easier to scale up while avoiding many of the ethical problems tied to lithium-based technologies. Recycling aluminum also uses only about 5% of the energy needed to extract it from raw ore. That is another major advantage in terms of both cost and environmental impact for building batteries on a massive scale. When it comes to safety, aluminum-ion batteries shine due to their use of non-volatile ionic liquid electrolytes. These materials are stable even at high temperatures up to 200 degrees Celsius and are chemically inert. That means they do not catch fire, even under extreme conditions. At Stanford University, researchers ran stress tests where they crushed, punctured, and short-circuited aluminum-ion batteries. Even then, they did not heat up or ignite. Plus, they can function safely in extreme weather conditions, anywhere from -50 degrees Celsius to 85 degrees Celsius, without losing performance. Whether you are driving in the freezing winters of Canada or under the scorching Arizona sun, these batteries remain reliable. Performance-wise, charging time is where aluminum-ion technology really grabs attention. Currently, lithium-ion batteries on Tesla's V3 superchargers peak at about 250 kilowatts, which still takes around 20 to 40 minutes to reach 80% charge. Early prototypes of aluminum-ion cells, however, have shown charging speeds over 1,000 kilowatts in short bursts, allowing small battery packs to fully charge in under 3 minutes. While larger battery packs in electric vehicles will likely settle around 350 to 500 kilowatts, this still slashes charging time dramatically. Imagine filling up your EV in the same time it takes to pump gasoline. That alone could eliminate one of the biggest psychological obstacles keeping people from going electric. Durability is another area where aluminum-ion technology could redefine expectations. Most lithium-ion batteries begin to wear out after 1,000 to 3,000 full charge cycles, depending on usage and thermal conditions. But aluminum-ion cells, especially those using carbon nanostructure cathodes, have already demonstrated cycling performance of up to 12,000 cycles without noticeable capacity loss. That could equal over 2,500,000 kilometers of driving range, assuming daily use of around 200 kilometers. For applications like aviation or long-haul trucking, this kind of lifespan could mean fewer replacements and lower long-term costs. For everyday drivers, it could mean battery warranties that last longer than most gas engines do. Energy density is also improving fast. Early versions of aluminum-ion cells had low voltage output, but thanks to innovations like three-dimensional graphene foam cathodes, new models are reaching over 1,350 watt-hours per liter in lab settings. That compares favorably to today's best lithium-ion cells, which usually fall between 700 and 900 watt-hours per liter. What does this mean? Smaller batteries with the same or better range, leaving extra room for design flexibility, crash protection, or even more spacious interiors, especially critical for compact cars like the Model 2. Imagine a $10,000 Tesla that charges in 5 minutes, lasts longer than the engine of most gas vehicles, and is safer by every measure. This could erase the last big excuse many people have about switching to electric concerns over range and charging time. For millions of drivers, this is not just an improvement. It could be the moment they decide to make the leap to electric for good. If you want a battery that could outlive your car, go ahead and comment Alu battery down below. But what exactly makes Tesla's aluminum-ion technology different from anything else in the world? This is not some off-the-shelf battery from a factory in China. Tesla is building a customized system designed to lead the next generation of energy storage. One of the most impressive innovations is the inclusion of self-healing electrodes. These use a silicon-aluminum hybrid material that can repair itself at the atomic level after each charging cycle. Normally, repeated expansion and contraction inside a battery causes microscopic cracks and long-term damage. But these self-healing materials can close those cracks automatically using smart bonding agents and polymer coatings. In lab tests, this has allowed the batteries to retain over 95% of their capacity after more than 5,000 deep charging cycles. By contrast, traditional lithium-ion batteries usually lose up to 30% over the same period. This could allow Tesla's aluminum-ion batteries to last for over 15,000 cycles while staying highly efficient. Tesla's new aluminum-ion battery is expected to use a soft pack design, meaning the cells are pouch-shaped and flexible, unlike the rigid cylindrical designs of the 2170 or B. 4,680 batteries in today's Tesla models. These soft packs use a multi-layer laminated film instead of a metal casing, making them lighter and fitter. Because there is no wasted space between the cells, these packs can offer up to 15% more usable internal volume. And since they are flexible, they can be placed in unconventional parts of a car, under the floor, inside door panels, even in the seats, freeing up room for design and safety features. The new soft pack design, with its thin profile of just 4 millimeters and reduced weight possibly up to 30% lighter than current lithium designs, helps make electric vehicles more efficient and roomier. Tesla is also changing how batteries are recycled. Instead of using harsh chemicals and high temperatures like most lithium battery recycling systems, Tesla is switching to a dry mechanical process. This involves separating the materials using physical methods like pressure, vibration, and magnets. The process generates no toxic waste, uses no dangerous acids, and can lower recycling costs by up to 40%. It is better for the planet, cheaper to operate, and easier to scale. Perhaps most importantly, aluminum-ion batteries allow Tesla to free itself from the tight and often politically sensitive lithium supply chains that are largely dominated by China. Since these batteries use no lithium at all, Tesla qualifies for full benefits under the United States Inflation Reduction Act, including up to $7,500 in tax credits per vehicle. It also means Tesla can take full control of its supply chain, avoid price swings, and reduce geopolitical risk. So why is the aluminum-ion battery the key to the Model 2's success? Because the electric vehicle market is still facing three huge challenges: cost, charging speed, and battery range. The Model 2 is Tesla's answer to all three, but it cannot work with old battery technology. It needs something revolutionary. Let's begin with price. A typical 60 kilowatt-hour lithium-ion battery costs Tesla around $7,800 more than one-third of the total car price. If aluminum-ion can reduce that by half, down to around $3,900, Tesla could sell the Model 2 for somewhere between $11,000 and $14,000 after tax credits. That would make it cheaper than a base Honda Civic, with far more features and full electric capabilities. Now consider charging time. Current lithium-ion packs still need 30 to 40 minutes to charge up to 80%. For people who drive every day or take long trips, that adds up. With aluminum-ion, a battery pack between 40 and 50 kilowatt-hours could fully charge in just 3 to 4 minutes. That is a complete game-changer. Urban drivers who cannot charge at home would no longer have to plan their day around charging stops. A quick coffee break could be all it takes to get back on the road. The lighter weight of aluminum-ion batteries also helps. Since they are up to 30% lighter, the Model 2 could weigh about 150 to 200 kilograms less than a comparable lithium model. That improves handling, extends range, and boosts overall efficiency. Even with a smaller battery, the Model 2 might easily reach 400 kilometers of range. Put this all together: lower cost, rapid charging, lighter build, better performance, and you have a truly practical electric car. Not just for the wealthy or tech-savvy, but for everyday people. Tesla's main rivals like BYD, General Motors, and Hyundai are still relying on older battery types. Tesla is not just keeping pace, it is pulling ahead by an entire generation of battery innovation. If your next car could charge in the same time as refueling a gasoline car, would that make electric vehicles unbeatable? Comment Model 2 if you think this changes the entire game. Lithium had its moment, but now it is time to move forward. Tesla is already doing it, and aluminum-ion is the technology leading that charge. Would you want to drive a car that charges in 5 minutes, lasts for decades, and never poses a fire risk? Leave your questions about this incredible new battery in the comments below. And do not forget to like, share, and subscribe to Amp Drive so you never miss a single update on Elon's quiet revolutions and Tesla's bold new future.